Hi everyone, so now we're going to be talking about linear and exponential equations. Once again, let's just go through this really fast. A linear equation has the form y is equal to mx plus b. You're adding or subtracting something every time, and it's a line, a straight line when you graph. An exponential function is in the form y is equal to a times b to the power of x. You're multiplying by something every time, and it's a curvy graph. It's growing really fast or getting really small really fast. So in this video, we're going to be talking about if you have 2 points and you want to write an equation, an exponential equation, this is how you do it. And then if you want to write a linear equation, this is how you do it. They end up being pretty different, even though we use the same points. So why don't we go ahead and get started with the examples? So the first example wants us to write an exponential equation through the point 0, 5 and 2, 45. So remember, your exponential equation is y is equal to a times b to the power of x. What I'm going to do is I'm going to start with my first point, which is 0, 5. Well, we know in 0, 5 that the 0 is the x and then the 5 is the y. What I'm going to do is replace the x and the y in my exponential equation with 0 and 5. So if I do that, then I'm going to get 5 for my y is equal to a times b to the power of 0. And now we're going to solve that for a, which actually is really easy because b to the power of 0, or anything to the power of 0, is 1, which really just cancels it out. So if I have something to the power of 0, I can cancel it out, which automatically tells me that a is equal to 5. Okay? Now that I know that a is equal to 5, I can rewrite my equation as y is equal to 5 instead of a times b to the power of x. Now what I'm going to do is do the same thing, but replace my x and y with my second point. So then I would have 45 is equal to 5 times b to the power of 2. And now this time we want to solve for b. So to solve for b, the first step is to divide both sides by 5 to get that b squared by itself. To get that b squared by itself. When I divide by 5, I get 9 is equal to b squared. And then I still want to get the b by itself, which means I need to get rid of the squared. To get rid of the squared, I'm going to square root. The other thing to do, if it was a higher exponent, like if it was b to the third or b to the fourth, you could always take the other side to the power of a fraction. So like I can say 9 to the power of 1/2. It'll be always 1 over whatever the exponent is. When I plug that into a calculator, I'm going to end up with 3, which means that b is equal to 3. Now, the good news is we're done. We just have to write the equation because now I know what a and b are. My final equation would be y is equal to my a, which we decided was 5, times my b, which we know is 3 now, to the power of x. And this is my exponential equation. Okay, so for the second example, we're going to use the same points, but now we're going to write a linear equation. So our linear equation is y is equal to mx plus b. And in this case, for linear, what we want to do is find the slope, or our m. And the slope formula, if you remember, is y2 minus y1 over x2 minus x1. Now, I'm going to just tell you that, or the first point is x1, y1, and the second point is x2, y2. So when I plug that into my slope formula, I'm going to end up with y2, which is 45, minus y1, which is 5, over x2, which is 2, minus x1, which is 0. When I plug that in, I get 40 over 2, which gives me 20. That's my slope. 20 is my slope. And then normally we could use like the point slope form to find the y-intercept, but because of the way that I have the points written out, automatically I know this first point right here gives me my y-intercept. And my y-intercept is just the y point of that. The reason why that's my y-intercept is because x is equal to 0. So when x is equal to 0, I have my y-intercept, which means that my overall equation will be y is equal to my m, which I just found, the 20x, plus the y-intercept, which is 5. And this is the linear equation. So I use the same exact points from the first example, but this is a totally different equation because it's linear instead of exponential. Okay, so now let's do the same thing. We're going to find an exponential equation and a linear equation using the same points. So my exponential equation again is y is equal to a times b to the power of x. I'm going to use this first x and y and replace that in my equation. So I'm going to have 40 is equal to a times b to the power of 0. Once again, you get this b to the power of 0, which means that we can cancel it out. And that tells me that a is equal to 40. Now that I know a is equal to 40, I'm going to write the equation y is equal to, instead of a, I'm going to use 40 times b to the power of x. And then we're going to replace the x and y with the second point, which would give us 5 is equal to 40 times b to the third. Okay, now what we can do is get the b by itself. So I'm going to divide each side by 40. And I get 5 over 40, which is simplified down to 1 over 8, is equal to b to the third. Now remember me telling you if you have a higher exponent that's squared, you don't square root, you take it to a power with a fraction. So this is a really good example. The way that I would write this is I would have, let me get my marker back out. It would be, I'm going to write it over here. So it would be 1/8 to the power of 1/3. Because the b is taken to the third power, I'm going to take the other side to the 1/3 power to make sure I know what b is. And 1/8 to the 1/3 power is 1/2, so b is equal to 1/2. Now that I know that b is equal to 1/2, I can write my equation, which would be y is equal to my a, which we know is 40, times your b, which is 1/2 to the power of x. This is my exponential equation through those 2 points. Now we're going to write the linear equation through the same 2 points, and remember the linear equation is y is equal to mx plus b. And I want to find my slope first, and the way I do that is with the slope formula, which is y2 minus y1 over x2 minus x1. When I plug and then you have x1, y1 is your first point, and x2, y2 is your second point. So when you plug everything in, you're going to have 5 for your x2 minus 40 for your x1 over 3 for your x2 minus 0 for your x1. 5 minus 40 is negative 35, and 3 minus 0 is 3. And normally I would have us simplify that, but that's as simple as it'll get. So our slope is negative 35 over 3. And then remember, our y-intercept comes from this first point because our x is 0. I know that my y-intercept is 40. So when I write that equation, it's going to be y is equal to the slope that I just found, the negative 35 over 3, times x, plus my y-intercept, which is the 40. And this is how you write the linear equation through those same 2 points. And there we have it, linear and exponential equations.